In this session, I am going to demonstrate the fourth problem in Java lab. The fourth problem is as follows. A program to input start and end limit and print all the Fibonacci numbers between the range. And they said to use the for loop. So what is the meaning of it? We are all familiar with the Fibonacci series, and the Fibonacci series is a very simple series, and you know very well Fibonacci series, some people say it doesn't start with the 0, but others agree that it starts with the 0. But in any case, we take the first two number, add them together, we get the third number, and we take the first two number, add them together, we get the third number. So you take the first two number 1 and 2, the previous two numbers 1 and 2, add them together and you get the next number. You take the previous two numbers 3 and 2 and 3, add them together, you get the next number. We are all familiar with the this Fibonacci series. Now what is that we are supposed to do is we are supposed to give a range. For example, if I give a range 1 and 10, let's say I will just type in between 1 and 10. Now all the Fibonacci numbers between this 1 and 10 has to be printed. So you are given a range 1 to 10. So which are the Fibonacci numbers which are there between 1 and 10? 1 is there. Again, we will not repeat 1 because number 1 is there. 2 is there. 3 is there. 5 is there. And 8 is there. So we are supposed to print 1, 2, 3, 5 and 8. So that is what the problem is all about. So you are given a range. That is what they are saying. So you are given a range here between the start and end limit, and we are supposed to print all the Fibonacci number. Now the question generally comes to your mind is, how do I know that a given number is a Fibonacci or not? So you are given a range. For example, suppose say you are given a number, say 1, and you are given the next number, that is the first number is the start number. So you have the start number and you have the end number. So you are given a range between the start and end. You are given two numbers between start and end. And how do I know that all the numbers between 1 and 10, you know very well, you have this 1, 2, 3, 4, 5, 6, 7, 8, 9, and naturally the 10 number is there. How do I know that 1 is a Fibonacci number, or 2 is a Fibonacci number, 3 is a Fibonacci number? You will say that okay, 1, 2, 3 are Fibonacci number because I gave you the Fibonacci number. Now suppose if somebody has given you the range between 50 and 250, how do you know, can you just tell me that whether it is 51, is it a Fibonacci number, whether it is 52, so after 50 you get 51, then you get 52, is 52 a Fibonacci number? How do we check whether a given number, any given number, for example if I give you 67 as one number, how do I tell that 67 is a Fibonacci number or not? Or suppose somebody randomly gives me a number 75, how do I know, how do I say that whether 75 is a Fibonacci number or not? So that is the first question that we are supposed to solve. Suppose if you know that if a given a general number, if a number n is given to me, then if I am able to say that n, whatever number may be, if it is a Fibonacci number or not, then my problem is completely solved. Suppose if you go to Google, you don't have to search anywhere. If you go to Google and if you just say check if the given number is Fibonacci or not, you just search for that, Google will give you a formula that says that a number is Fibonacci if and only if 5n square, this is 5n square plus 4, or 5n square minus 4 is a perfect square. So what the Google says is, you take n, suppose you have a doubt, given a number, so randomly I will take, given a number n may be 10, 20, 30, 40, whatever, given a number n, how do I know that n is a Fibonacci number or not? Google says a very simple thing. You take 5n square plus 4 or 5n square minus 4. It will be a perfect square. So if given number, suppose if you are given a number, suppose I am not saying that is the number, suppose say assume that if you take the 55 given number 55, so you take 5 into 55 square plus 4 or 5 into 55 square, this is the n, if minus 4, if it is a perfect square, then 55 is a Fibonacci number. If it is not a perfect square, then this is not a Fibonacci number. So this is what we are supposed to do it. So how do I do that thing? So that question will come to, naturally that will come to our mind. How do I go about it? First you take, that is what they have said. They said that you take the for loop and generate. This is what they said, use the for loop and generate. So for example, if somebody says that okay, tell me all the numbers between 25 and 255, tell me all number between 25 and 255, you take a for loop. For I is equal to 25 up to 255, take one number 25, check whether 25 plus 25 square into 5 plus 4 or 25 square into 5 minus 4. If it is a perfect square, then it is a Fibonacci number, otherwise it's not a Fibonacci number. Now the question for some people, this question may come, what is a perfect square now? So what is a perfect square? Again, if you have if you go to Google and ask Google, okay, what is a perfect square, tell me what is a perfect square. So 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, 16 is a perfect square. So what is this perfect square? If you take the square root of 9, so let's say you take the square root of 9. So what is the square root of 9? Square root of 9 is 3. So 3 is an integer. So 3 into 3 is 9. What is the square root of 10 then? So if you ask that question, what is the square root of 10? So for that, I'm going to go to the calculator here and I'm going to take 10 and I'm going to take the square root. Okay, square root of 10 is 3.16. You notice that it is a fraction. 3.1617, whatever it is a fraction. What about the 9? If you take the 9 and take the square root of 9 is 3. So if you multiply a integer number and if you get the square, okay, or if you when you take the square root, if you get a integer, or that is a whole number without fraction, then it is a perfect square. So which are the other perfect square? You have 16 is a perfect square because if you take the square root, it is 4. What about 20? 20 is not a perfect square because if you take the square root, it is 4 point something. You should not get point something. Fraction should not be there. So if you take a number and if you take the number and if you take the square root of a number and if you take the integer part and if you multiply them together, for example, you take the 10 and you take the square of the 10 and take only the integer part. What is the integer part? Integer part will be 3 here in this case. Just a minute. Integer part will be 3. So 3 into, forget the fraction part, 3 into 3 is 9, not 10. It is not 10. So that means to say that 10 is not a perfect square. Now what if I want to know whether 25 is a perfect square? You take the 25, you take the square root of 25, take the integer part. You notice that there is no fraction part. What is the integer part? Integer part is 5. So 5 into 5. So 5 into 5, what is the answer you get? 5 into 5 is 25. So this is, then you can say 25 is a perfect square. What about 28? you take 28, you take the square root of 28. So square root of 28 is 5.29 and thing. You take the integer part of that. So what is the integer part? A remaining part you don't take. This part you don't take. So what is the integer part? Integer part is 5. So 5 into 5 is 25 and not the answer 28. So this is not equal to 28. That means to say that 28 is not a perfect square. So what is that we are supposed to do now? We are supposed to check whether given number is a perfect square or not. So let us take these numbers first and then find out whether this number itself is a perfect square or not. So I will not take with the 1, forget that 1, you will not get any good with 1 and 0, you may not be able to get wonders. So let's go start with the 2. Okay, so I take this 2. What is the formula here? 5n square, 5 into, I'm taking 2 here, 5 into 2 square, okay, n square, so that is this n square, plus 4 as in the formula, and 5 into 2 square, so same thing, minus 4. Okay, so what is 2 square? 2 square is 4. 5 into 4 plus 4, so this becomes 5 into 2 square is 4, so 5 into 4 into 4, again 2 square is 4, 5 into 4 minus 4, so 5 into 4 is 20, 20 plus 4 is 24. 24 is not a perfect square, we know that. Let's look at this one. 5 into 2 square, I am taking for 2 now, 5 into 2 square minus 4. For one you have plus, for the other one you have minus, so this is plus, the other one is minus. 2 square is 4, 5 into 4 is 20, 20 minus 4 is 16, and you know very well 16 is a perfect square. What is the square root of 16? Square root of 16 is 4, which is a whole number. So you notice that the number 2, which is part of the Fibonacci series, you know that Fibonacci series starts with 0, 1, 1, 2. So number 2 is a Fibonacci number or Fibonacci element, because 5n square minus 4 gives you the answer 16, which is a perfect square. So either 5n square plus 4 or 5n square minus 4, one among them, either this or that, one among them will be a perfect square. So one among them will be perfect square. Let's look at the next number 3. I'm going to take the next number 3. Let's take the equation. This is same, 5n square minus 4 and 5n square plus 4 and 5n square minus 4. The number is 3 that I'm taking. So 3 into 5 into 3 square plus 4 and 5 into 3 square minus 4. So n instead of n, I'm taking 3 now. So this is 5 into 3 square minus plus 4, 5 into 3 square minus 4. 3 square you know very well, 3 into 3 is 9, 5 into 9 plus 4, so 5 into 9 is 45, 45 plus 4 is 49, and what is this 49? By the way, 49 is 7 square, 7 into 7, so you got the perfect square here. What about the other part? 5 into 3 square minus 4, so 3 square is 9, so 5 into 9 is 45, 45 minus 4 is 49. Now 41 is not a perfect square, but the first one is perfect square. So either, in other words, either this will be a perfect square or this will be the perfect square. One among them will be the perfect square, either 5n square minus 4 or 5n square plus 4. Both may need not be. One of them will be true. Let's go for the next number, that is 5. So let's see, this is also part of the Fibonacci series. You know that all these are Fibonacci series. So next number in the Fibonacci series, 5. I'm going to take 5. So instead of n, I'm going to substitute 5. So 5 into 5 square plus 4, 5 into 5 square minus 4. So let's put that thing. 5 into 5 square plus 4, 5 into 5 square minus 4, 5 into 5 square is 25. plus 4. 5 into 25 is 125. 125 plus 4 is 129, which is not a perfect square. Let's go to the other side and figure out what is the answer. 5n square minus, this is 5n square minus 4. I am using this formula. So so this is going to be 5 into 5 square, that is 5 square is 25. 5 into 25 is 125 minus 4. 125 minus 4 is 121. What is 121? Square root of 121 is 11. 11 into 11 is 121. 11 is a whole number, so that means it is a perfect square. So 5 is also a Fibonacci element. Now let's look at the element that we have missed. In between 3 and 5 there is one element 4. You know very well, there is number 4 is there in between, but you know very well 4 is not a Fibonacci element. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5. 4 is not a Fibonacci element. So what if I take n equal to 4? So if I put 4 here, 4 square and 4 square minus, am I getting a perfect square or not? Let's look at that. So I take n equal to 4 now, one element which is not a Fibonacci element. I substitute. So 5 into 4 square plus 4 and 5 into 4 square minus 4. 4 square is 16. So 5 into 16 is 80. 80 plus 4 is 84. 84 is not a perfect square. Let's go for the other one. 4 square minus 4. So 4 square is 16. 5 into 4, 5 into 16 is 80. 80 minus 4 is 76. Both are not perfect square. So you notice that elements which are not part of the Fibonacci series, in this case the element number 4 is not, if you substitute that element in this expression over here, you will not get them as perfect square. Similarly, I can go on giving you the explanation for 6, 7 and so on, but if you try on your own, you will find that they will not give you the perfect square. So this is what we are supposed to do. We take any element, say let's take the element I. If you take the element as I, what you are supposed to do, 5 into I square plus 4 and 5 into I square minus 4. We have to check whether that element 5 into I square plus 4 and 5 into I square minus 4, whether one among them is a perfect square. If it is a perfect square, we can say that that is the Fibonacci element. So let's go to the our NetBeans and let's try to create a new project. So in the NetBeans, I'm going to go and I'm going to say file and I'm going to say new project. Under the new project, I will select Java as my project and I'm going to click on Java application. Click next and give any name for your project, and I'm going to say this is let's say Fibo range. Okay, Fibo. What you give any name, or even if you don't give the name, it will take the default name. Just click on finish and NetBeans will create a project for you. So what is that we are supposed to do? In this exercise, there are two inputs that we are supposed to get. What are those two input? The start and the end limit. So you must know where to start. For example, start from 1, go up to 10. So start and end. Or somebody may say start from 50, go up to 250. So you must get these two input from the user. Get the start and get the end. So let's get the start and end. How do you do it in a C program? In a C program, you have I'm going to take this remark statement, which is of no use to us, and also I'm going to take this remark statement also. The remark statements are not required as far as my demonstration is concerned, but when you are when you are taking the printout of your exercises of the remark statements are absolutely required for documentation purpose. So now in your C program you have scanf function which will take the input, but we don't have the scanf here. Instead we are going to use similar to scanf, we have something called as a scanner. So I'm going to type SCNENN and the Java will give you scanner. If you look at this one, Java, okay, scanner, okay, simple scanner which are able to take the text as well as integers. So you can use this to take the input. So to use this you have to import java.utilities. Now if you just select here and press enter, Java will the NetBeans will automatically import java.utility.scanner. So you know very well, in order to use the scanner or printf, scanf and printf function, you are writing include stdio.h. So here you have to say import java.util.scanner. Without this, the scanner will not work. Now, in then I'm going to take one variable. So let me just say this is same as writing int x, where int is the data type and x is a variable. Similarly, scanner is the type and sc is the variable. It is same as your C program, but here generally sometimes you write like this: int x equal to 10 you or 20, you assign the values. So you assign 20, you initialize x with the 20. Similarly, you have to initialize ESC with not 20 because it is not an integer, it is not a float, it is not a character, it is a class. So you have to give it a object. How do I create an object? Using the operator new, I can say scanner. Now scanner is one particular class that can take input from the file, input from all many things. I want it to take the input from the IO stream, that is from my keyboard. So I want it to take the input from the keyboard, not from the file, not from the readable and so on and so forth. I want it from the input stream. So here it now says give me the input stream. Input stream is in system. Okay, I want the input. IN is for input. Now if you put control space here, NetBeans will give you many other options, input, output and so on and so forth. Okay, input is system input. What is system input? In generally system input is your keyboard. Okay, so in a very simple way I am saying that SC is a variable that can take input from your keyboard. So it is like your scanf function. So you can take any variable, you can take scanf itself as a variable, but I take that. Now I need two values. What is the starting value and ending value? So I'll take int start, the starting value, and int end, the ending value. So two things I have. One is the starting and the ending. Now I'm going to give the yes out. Yes out, you know very well, it is used to output. So here you notice that system.in is there, that is for input. System.out is there, you know very well, that is for the output. So we say enter, let's say enter the start and end value of the range. Now one small thing I am going to do, you know very well, ln stands for new line. I'm going to say print. If you say print, that means it will not take you to the next line. Okay, simple as that. Let me just show you that. So when, let me zoom it out, if you just run this one without anything, if you just run it, in the output, oh, did I deleted something? I think I deleted something during my program. Okay, let me go here and to my project, and I'm going to say clean and rebuild. Okay, so that I'm getting some error when I talking. I might have deleted something. Let's say it is running. It just says no. Okay, I'm going to just create a new project. I think when I was talking to you, I deleted something in between. So I'm going to just create a blank project. Sorry about that. And I will continue from the point where I stopped. So I created the scanner. SC equal to new scanner. Inside this, I said system dot in, okay, and then I created two variable int start and int end. Okay, two variables were created. Let me save and run this project. Let's see whether it just runs. Okay, now build successful, and after this what I have written here is assume that I don't want to waste your time as well as my time. Okay, and I am going to just say, okay, enter the start and end values for the range. Okay, I have typed that thing for the range. Now what is that I want to demonstrate here is when you use print line, what happens is the cursor will go to the next line. So this cursor will go to the next line. If you are using print as such, if you just use print, the cursor will remain there itself. So it will remain here itself. You notice that it was the previous case, if this whole thing, this is not of any use to you. It used to come in the next line. Now this time it is coming on the next line. So if I just make it as print ln after the last character, it will take you to the next line. So you notice after this it will add enter, you know very well, that is /n in your C program. You notice you have already studied this one, /n new line. So it will add, when you say it is print ln, it's going to add a new line and the cursor will go to the next line. So I don't want the cursor to go to the next line, so I'm going to just make it as ln. Then I'm going to read the two characters here. So what are the two characters that I'm supposed to read, two values that I'm supposed to read is the start and end. I'm going to say start equal to SC is my scanf like function. So SC dot next, I'm going to say next int. Remember, if you notice here, if you just write, you can read next byte, next int, next short, next float, next double, you can read anything. So next followed by anything, you are going to read it. So this is the start, and I'm going to read the next number, that is SC dot next int. Because why I'm reading int? Because I have declared start and end as integer variables. That is why I am reading it as int. I am reading it as int. If I declare it as long here, then I can say next long. Notice that. Okay, but I am not doing it. I will read it as int. So let me make it as int. Okay, don't get confused. I read it as int. Now I'm going to just run this one and I'm going to show you what is the effect. Now when you run the program, you notice that the cursor is here itself. So here you can write 1 to 10, 1 space 10. Okay, and the program will not do anything, no doubt. But what if I take this one, I change this one, and if I make it as print ln, if I make it as println and if I run it, what is it going to do? It's going to take me to the next line. You notice that the range will come in next line. Automatically it will add a new line and the input will go to the next line. So I don't want that new line to appear, so I will just use println. Now what is that we are supposed to do it? According to the program, we are supposed to use a for loop. So I'm going to just use the for and press tab. So it will start for I is equal to 0, but it is not I is equal to 0. I is equal to start till I is equal to, remember, not just less than, equal to end. So from starting to the end. So what is the meaning of it? Suppose if you give two numbers here. So if you give two numbers, starting is equal to, if you type 10 here, ending is equal to 100. So you are supposed to start from for I is equal to 10 till I is equal to 100. All the Fibonacci element between 1 and 100 has to be calculated. How do we calculate whether the ith value, I is equal to 1, 2, 3, 4, 5, 6 and up to 100. So how do I know that when I is equal to 5, whether 5 is a Fibonacci series or not? How do we do that thing? To do that thing, we have the formula here. What is this formula? 5n square minus 4 and 5n square plus 4. You have to calculate. Let me take this expression 5n square plus 4, 5n square minus 4. Let me take them as x and y. You can take anything of your choice. So I'll take two more variables here. Look at here. I'll take two variables again of type integer, x comma y. Two variables, x and y. So what is x? X is 5n square. You know very well, 5n square minus 4. So I am going to take 5. Here it is not n because I is changing. I is changing from 1 to 100. So I square. What is square? I into I. N into n. 5 into 5 is 5 square. 2 into 2 is 2 square, like that. So 5 into 5 plus 4. This is the first one. So this is what is this? 5i into I plus 4. What is this one that I have typed? This is what I am typing here. So 5 instead of n, I am taking it as I. So 5n square plus 4. What is square? I into I is I square. So you know I into I is I square. So this is simple as that. 5n square plus 4. What is the next one? 5n square minus 4. So let me take this one also. 5n square minus 4. So let me take that one. Y is equal to 5 into I minus 4. So that is the second one. So you got two values here. How do we check that this is a perfect square or not? How do you say that given a number, let me go over here. How do you say that given a number 16, whether 16 is a perfect square or not? How do you do that? Take the square root of 16. What is the square root of 16? Square root of the 16 you may get to 4.0, not 1, sorry, 4.0. Take the integer part of it. Integer part of it is 4. So multiply 4 into 4. What is 4 into 4? 4 into 4 is 16. So when you take the integer part and if you multiply, if you get the same number, then it is a perfect square. Now suppose if you are given a number 18, so if you take the square root of 18, let's assume it may not be the perfect answer, you may get 4.1234 something, you may get it. So I am not doing the calculation, there is no computer inside my brain to get the square root of 18, but let's assume that square root of 18 is 1.4 something. You take the integer part, forget the fraction part, take only the integer part of it. When you take the integer part, multiply 4 into 4, the fraction part you don't take it. 4 into 4, what is 4 into 4? 4 into 4 is 16. 16 is not equal to 18. So that means to say that 18 is not a perfect square. So what you need to do is take the square root of a given number and take the integer part of it. From the square root, take the integer part of it. So how do I do that? So you have two numbers over here. Which are those two numbers? 5n square plus 4, 5n square minus 4. This number x is that number 16, 18, whatever you get. When you multiply this whole number, you get some number, 16, 18, 20, whatever it is. You take the square root of this number. I need two more variable, so I am going to say square root of x and square root of y. I take the square root of x and square root of y. So what is the square root of x? Square root of the x, you know very well, in C you had this function sqrt. Okay, but here for that you used to import math.h. I don't know whether you imported it or not. Math.h was the header file. Now here also you have sqrt. I press control space, and what the NetBeans will say, there is a math package. Inside that you get square root dot h. So math dot square root dot that. So math dot square root of x. You get that thing. Now one important thing, let me do it one more time. I will just type sqrt and control space. Now you notice this a double, it says double. What is the meaning of that? It returns not integer. Square root always returns a double. What is the meaning of it? Whenever you take the square root of 16, what you get is not integer value. What you get, generally what you get is 4.0. Okay, what about the square root of 20? When you take the square root of 20, square root of 20 may be 4.2 point something. You may get something, you may get it. So you always get a fraction. So return value is always a fraction. It's not an integer. So what the square root is returning, what this function is returning is double. Okay, that is the fraction, but you have to convert that fraction. You have to ignore this fraction part and take only the integer part. Okay, how do I do that thing? So that is the next part. So I'm going to go over here, control space, enter. So I'll take the square root of x. I got the square root of x, and NetBeans is not happy. NetBeans just to say that it is incompatible. Why? And it just say possible loss because of the conversion from double to int. This is returning double. And what is sx? Sx is integer. So one side you have integer, other side you have floating point number. Both are mismatching. One there is a fraction, other side you have whole number. Whole number is not equal to fraction. So it says you need to convert them. So how do I do that? If you click on this one, it just say classed square root to integer. If you just click on this one, it will do it. Otherwise, if you are not so lazy, you can also typecast it. In C you might have learnt this one, typecasting it. What is typecasting it? This is returning double to you. Temporarily you convert it into integer. What is the meaning of it? This side you may get the answer as 4.2.1, 4.2.35 and other things. So you just tell the Java that ignore the fraction part, only give me the integer part. So give me only the integer part. This is what is the meaning. So you say give me only the integer part, don't give me the fraction part. That is what is the meaning of saying typecasting it. You just typecast it. Similarly, I am going to do it for, this is for 5n square plus 4, this is 5n square minus 4. Similarly, I am going to do it for the other one. So how do I do it? Again, I am going to write sqrt because I have the NetBeans to help me out with that. So y, I am going to take it. So I take the square root of y. So y, this is not x, so yes, y. Okay, so this is the next variable, square root of y. And this time I am not going to be so lazy. I am going to say typecast it into integer. So typecast it into, how do you write typecast? Inside the circular bracket you write data type, it will do it. Now what is that we are supposed to do it? So what is that? We did it from the beginning. So we had a doubt whether 16 was a perfect square or not. What did we do? We took the square root of 16, and what is the answer that we got? This answer we got 4.0. And what did we do? We took the integer part, and that is what we are taking, integer part. And what did we do? Integer part, we multiply it, integer part into integer part, and we check whether the answer is same as the given number. Okay, so for example, you had a doubt whether 18 was a perfect square or not. You take the 18 and you got the answer. Let's say 4.12 something, you got it. You take the integer part of it. So integer part of it is 4. Forget the fraction part, you just take the integer part, 4, multiply it again with 4. So 4 into 4, which is definitely 16. And what was the given number? Given number was 18, and what you are getting is 16. Both of them are not same. That means to say that 18 is not a perfect square. Similarly, you have x here. You have a given number x here. So in this case, you have x here. Take the square root of x. You will get the square root of x as 4.1235 something. You take the integer part of it and ignore the fraction part of it. What you get when you take the integer part of it, you get sx. This is what you get it, sx. When you take the integer part, when you take x, you get and when you take the square root of x, you get a number. When you take the integer part, you get sx. So what is that you are supposed to do it? You are supposed to multiply sx with sx again. So how did you do? 4 into 4, same thing. You get sx here, not 4. So sx into sx. Whatever answer you are getting, compare it with the original x. If it is same, sx into sx, if it is same as x, it is a perfect square. If it is not, then it is not a perfect square. In the same way, you wanted to check whether y is a perfect square. Then what did you do? You take the y, square root of y, you get some value 4.56 or something. You may get something. You ignore the fraction part. You take only the integer part. So when you take the integer part, what is the answer you are going to get? You are going to get the xy. So that is what, when you take the integer part, you get sy. Okay, you multiply sy into sy and check whether this answer is same as y. Now the square root, just the y. If the answer is equal to y, then it is a perfect square. If it is not, and it is not the perfect square. So that is what I am going to say. So I am going to compare whether sx into sx is it equal to x, or sy into sy, whether it is equal to y. So I am going to do that thing here. So I am going to go over here and I am going to say if sx into sx, whether is it equal to x. So that's the first part. Or sy into sy, is it equal to y. If any one of them is true, that means you got it as a perfect square. What is that you are going to do it? You are going to print it. That's all. So I will do here. I am going to print the I, not the x or y. Remember, what is x after all? What is x? X is I into I. I wanted to check whether I is the Fibonacci number or not. Remember, so you start from where did you start? After all, where did you start? You started for I is equal to start till I is equal to end. So I is from 1 to 10. You wanted to check whether the I value, I equal to 1, 2, 3, 4, 5, 6. So this will go on taking 1 value. So it will start from 1. Next time it is going to take 2, 3, 4, 5, 6 and so on. So you take this I, you take 5n square. That is 5i square. So you are checking for whether I is Fibonacci number or not. What is this condition? If this condition, if any one of this condition is satisfied, then I is a Fibonacci number. So I say I plus space. Now some of you may get, hey, what is this you are doing? You are concatenating. So I will not go in depth into Java. What is the meaning of this is if you add anything to string, this is actually string, you know very well, whatever you type inside double quote is a string. So space is also a string. If you add anything to a string, it becomes string. So simple. You add any integer, float, anything, you take anything, integer, float, to anything, you add it to string, it just becomes string. Why do we have to do it? Because that's how we print the value in Java. There is other way around, you can do it. That's all you need to do it. Okay, I'm going to just make it slightly better. No, the program is perfect here, but to get that feel that you are going to generate something, so I'm going to use one print line statement. This is not really required, one line to say that what is that I'm generating. So I'm going to say Fibonacci elements in the range are, okay, so you are given a range start and end. So within this how many Fibonacci elements are there? So that's what I'm just printing, that one line. This print line is not really required. During the examination you can ignore it and reduce the typing speed, typing time. So with that everything is done. Let's run it and let's give it a final try. I have some issue. Okay, it is already running. Let me see the output here. Okay, it is already running. So let's run it one more time. That time it was running. So this is what it is saying. So look at here. What does it say? Enter the start and end value for the range. So enter the start and end value of the range, and you are going to input to start and end, these two values. So you are going to input those two values. Let me go here into the output and let me type from 1 and 10, 1 to 10, 1 space 10. So 1 to 10, how many are there? So you notice that from 1 and 10, after this you get this statement, Fibonacci elements in the range are. So this is what I used it for, because when you take the output you must know what is that you are getting. Fibonacci element in the range are 1, 2, 3, 4 and so on. Now you notice that they are coming one below the other, but I want them to come in one full line. What is that we are supposed to do? I have already told you, if you put ln in the print line, it will give you the next line. So I don't want whenever I am printing the value of I, that is this value I, 1, 2, 3 and whatever, whenever I print the value of I don't want it to go to the next line, so that it will not come one below the other. So what I'm going to do here is I'm going to just print ln means line, print a new line. So I don't want it to print the next line. So what is the difference? You notice that I values are printing one below the other. Now when I run for the same value, when I run it, I give the same answer, I mean same range from 1 space 10, I give the range. Press enter, you get all of them. Okay, 1, 2, 3, 4, 8, and you notice, oh, this is it is one extra thing. But remember, this is just to tell this is how the NetBeans says that it is able to execute it within 8 seconds. So that's good. Okay, but we are not here for efficiency and other thing. You study data structure where you study about the algorithm that is very efficient and so on. Here we are not doing it. So at last, this is the for loop. So how do I know that this for loop ends? Where is it going to end? Some of you really don't know. So you just click on this. You notice I click on the first starting flower bracket. What NetBeans will do is it will give you the yellow line saying that this is the end. Can you see there? Okay, I don't know whether that mouse pointer is available when I zoom out. So this, if you click on any of this flower bracket, it shows where that, from where to where that flower bracket exists. From here to here, this is the flower bracket. Yellow color, it will highlight it. Say that that's a flower bracket. So after this for loop, this is the opening flower bracket of the for loop, ending flower bracket. Remember, these are not really required. This I'm doing it just for so that you get a neat output. So sometimes they say formatting 4 marks are there for your during your practicals. That is why I'm doing it. So I'm going to just the S out. I'm not going to print anything. What is the purpose of this S out? I just want a new line. That's all. So what's the difference? With this, remember, I have put it after the for loop. After the for loop, I put a new line. This is just a new line. So in other words, I want this build successful whatever it is to come. This is the range. This is a Fibonacci number. After this, I want a new line so that this whole thing, whatever it is printing, this is not printed by me, it is printed by NetBeans. Let it go to the next line. So I'm going to run it again. This is the last time I'm going to run it. So I'm going to run it. So 1 to 10, and you get it. Fibonacci element is 1, 2, 3, 4, and you notice that because it went to the new line, because I have printed ln. My intention here was to print one new line, and that is what, after printing all the numbers, I put one new line. That's all, simple, one new line to take it to the next line. So is all these things are there in the Fibonacci series, if you wonder whether it is there or not. And if I go to Microsoft Word and I started from here and said that these are the elements of the Fibonacci series, and what you notice that these from between 1 and 10 you have up to 8. So from here to here. Now let's say if you give very large range, if you give very large range, whether are you going to get the number. So I'm going to say that between 50 and 250, give me all the Fibonacci element between the 50 and 51, 52, 53, like that. Tell me which among them are all Fibonacci elements. So if I press enter, it's going to say 55, 89, 144 and 233 are the Fibonacci element. Are you sure whether they are the Fibonacci element? I cannot judge whether 55 is a Fibonacci element, but I can definitely check whether the 144 is it a Fibonacci element. What is a Fibonacci element? Sum of the previous two must be equal to the next number. I'm going to just zoom out for you. So I don't know whether it is going to be visible to you. Or 55 plus 89. What is 55 plus 89? Is 144. Let's take the other two element, 89 plus 144. What is 89 plus 144? Is 233. So sum of the a plus b. So this is what you said, a plus b equal to c. So c is equal to a plus b. Fibonacci series from your c. So a plus b, this is a plus b is equal to c. So you get, that is a Fibonacci series. That's all in this video. We will meet again in the next class. Thank you.